Hey, good morning, everybody. On the Joe and Friends show today, we have Matt Rocklin. He's the CEO of Coiled, and he's also the creator of Dask, which you may have heard of. What's up, Matt? Good to have you on.
Hey, Joe. Hey, friends.
Hey, how's it going? It is Joe and Friends, so glad to have you on. So, yeah, for people who don't know who you are, do you want to give a quick intro?
Yeah, sure. So my name is Matthew Rocklin. I've been an open source software developer in the Python space for a long time. So libraries like NumPy, Pandas, Jupyter, Scikit-learn, that's sort of like the crowd that I've been with for a while. Inside of that group, I mostly think about how to scale out that ecosystem of libraries. And I did that mostly with the library Dask, but there's been like a huge effort around Python to get out of single machines on multiple machines, which extends far beyond Dask. A quick edit. So I wouldn't call myself the creator of Dask. There are many creators of Dask,
Right.
but I have the honor of being sort of the author on the first commit.
Okay. What was it? What was the first line of code that you wrote for Dask?
The first commit was I think it was like 14 lines, and it was the simplest task scheduler I could write. So a task scheduler, something that is given a plan of things to run, and it tries to run them in parallel. And so we managed to get that done in 14 lines. And actually, I think there are still Dask competitions that would still run on that very first scheduler.
No way.
It's evolved quite a bit since then, but that was the core. And then on top of that little core, we built off all sorts of different things.
Interesting. When did you create Dask, and kind of walk me through that? When did you create it, and what gave you the inspiration to start this project?
Well, I gotta say, first, not creator, first author.
Author
was
of this project. Right.
That was in 2016, 2015, something like that, 6, 7, 8 years ago. I was working at Anaconda at the time. Anaconda at the time was sort of the de facto for-profit Python company. And everyone who cared about open source and Python was working at Anaconda. It was sort of the place to be. People loved using Python on single machines. It was fast, or at least fast enough. It was really easy to use, and it could do everything people wanted to do. It had a really broad, really just a strong breadth of functionality. But this is the era of big data. Big data was becoming more and more of a thing, and Python didn't have a big data story, except for Hadoop and Spark. And neither of which were really a pleasant experience for the Python user base or for the Python ecosystem. So you're trying to find something that could do kind of what Spark did, but in a much more Python native way. So that was the sort of initial cause behind Dask.
Interesting. Yeah, I remember obviously NumPy and Pandas way back in the day, and they still are the tools of the trade, right? But I definitely feel your pain that you went through. A similar story. It was it works on your machine until it doesn't. Spark back then, you're better off just learning Scala. To be frank, it's just the Python experience was pretty poor. So for performance wise, yeah.
Certainly Spark experts use Scala, but I mean, I think if you look at Spark today, I think Databricks runs a survey every year, and they talk about their user base, and it's 60-70% Python usage.
Right. Yeah.
So certainly Python has won the language game. Spark is definitely the de facto scale out story today. But I think as people, what we saw with our first attempt to do this was just to use Spark and to use Spark and Pandas together. I think Holden Crow had a fun project, Sparkling Pandas, way back in the day.
Oh, I remember that, actually.
Yeah. And there were some challenges, right? It's really awkward using JVM that holds Python, that talks to another JVM that holds Python. That's strange. The APIs were different. They were strange. Also, Spark just couldn't do a lot of things. Spark fundamentally was sort of a MapReduce paradigm. So it's much, much more efficient than Hadoop MapReduce, but it's still very much, I got all this data. I want to do the same thing on that data. I want to shuffle that data. I then want to reduce those results. And you can do lots of things with that paradigm, build a whole SQL engine, but you can't do something like, non-trivial machine learning, or you can't do, gridded data very well. You can't do, time series analysis quite as naturally as you could with some other paradigm. And so Spark just didn't fit the complexity of applications people were using in Python. Spark is really, really solid for sort of classic enterprise business computing. I've got a pile of JSON, throw in a pile of Parquet, run a SQL query on it. It's not really good if you want to do something that's more complicated, that has more more richness to it. And that's where a lot of Python players play. And so Dask had to be a lot more flexible as a result.
Interesting. Back in those early days, I mean, you kind of mentioned the JVM. Did you attempt to use like, was it Python or whatever it was?
No, I mean, the whole goal was to make something that was pure Python, that would be native to Python users.
Okay.
That would be, that could integrate really well into the existing Python stack. Using pandas from Python isn't really a doable thing, right?
Yeah.
There have been so many attempts to redo Python and something that's not CPython. And the Python language itself isn't what people care about. They care about the rich ecosystem of libraries that's written on top of Python. That's really the thing to pull over. So that's why no one has ever displaced CPython as a standard interpreter.
Right. Yeah, it makes sense. We've seen a lot of attempts to do that, and hasn't really come to fruition.
There are also some great attempts happening right now. So there's Cinder coming out of Instagram and Meta, Facebook. There's a no-gil project. People are really embracing CPython and trying to fork it and evolve it. Like Python is actually evolving quite a bit at the core level. I think in the next year or two, we're going to see significant
That's awesome.
sort of V8 style performance improvements.
Wow.
But yeah, gone are the days where Python makes sense or Iron Python makes sense.
I haven't heard of those since like the early 2010s or something. So that's interesting. I mean, so I mean, with these new improvements coming out, I mean, you know, in the Python language and CPython, where does that leave Dask? Does that make Dask more powerful, or how does that impact the?
Yeah. So one of the core principles of Dask is that we don't try to own the entire stack. We play very well with other libraries. And so if you're using, so let me just take a step back for a second and describe Dask and how it's used today, and then I'll try to answer your question. So people use Dask today either as sort of a Spark replacement. So they use Dask with a library like Pandas to do, you know, read a big Parquet file, do some group aggregations, do some SQL queries, throw into XGBoost, train a model. That's sort of one class of use cases with Dask. And that's very, very common. They might also use that not with Pandas, but with NumPy on, you know, gridded data like, you know, biomedical imaging, like an MRI data set, or, you know, looking at climate simulations. Dask is very, very good at providing those sort of high-level APIs around existing Python interfaces, but that operate not on gigabytes, but on terabytes or petabytes. People also use Dask just to scale out their own custom code. Right? So Dask works with any library. You can call arbitrary Python functions, you know, 1,000 times. You can relate them to each other in different ways. You can really integrate Dask into your own library or into your own code to run it at scale. And that's a much more sort of low level, much more bespoke, much more custom deployment. So to your question is, you know, well, what happens as Python gets better? Does that mean that Dask it gets relatively worse? No, Dask is just augmenting all those existing libraries. As Pandas gets better, Dask plus Pandas gets better. As you start seeing new libraries, you know, like Rapids or Arrow, you know, people use those libraries with Dask. Dask follows the sort of Bazaar rather than Cathedral model that's really common in Python, where we do one thing really well. We handle distributed computing, but we leave all of the other pieces of computing to other libraries, and we really focus on protocols and working nicely with those groups.
That's really cool.
So
it kind of reminds me of Flask, which sort of rhymes with Dask. Just that it does one thing well, and you can tack on a bunch of stuff. I don't know if that was intentional or not, but
not intentional. But yeah,
yeah, similar approach. I like that. The Cathedral and Bazaar analogy, I think, is one that. Do you want to walk the audience through that real quick? Like, what exactly does that mean? Because this pops up, I think, in programming circles occasionally, but it's actually a pretty profound and useful idea.
Yeah, sure. That's a great. Yeah, I think programmers talk about that all the time, but it's good to mention it a few times. So if you think of it like an old town, both the Cathedral and the Bazaar are both examples of very rich things that society has built, but they've built them in very different ways. The Cathedral, there's some central architect that has everything in their brain, and they organize lots of people to build one thing together. And that's it's a great edifice to, you know, whatever. But it's complex, it's sophisticated, it runs really, really well. The Bazaar takes a very different approach on how it's built. So in the Bazaar, like a marketplace, when I say Bazaar, I mean a marketplace. Someone pitches a tent and they start selling something. And someone else sees that and they pitch a tent just next door and they start selling something too. And over time, you know, hundreds of people have pitched tents. They're all selling different things. And they naturally organize some roads. They naturally organize, you know, how the garbage is picked up. They naturally organize a way to communicate amongst each other. And so the Bazaar is as complex, as rich, as functional as the Cathedral, but it's built in a very different way. It's built in a much more organic way. And so similarly, you can look at some software projects, maybe like Spark. Spark is maybe more Cathedral-like. There's one central repository, there's one central planning system. Everyone works on the same thing together. In something like Python or PyData, it's much more like the Bazaar. There's no central governance. Everyone makes their own little small project. And then the interesting thing happens about where people figure out how to build roads or how to build sanitation or how to build things among that Bazaar. And so there's no centralized control. It's a bunch of independent actors operating and trying to collaborate, but in a much more loose way. And so it's actually interesting. So Dask, we're trying to do this thing. We're trying to lift up that Bazaar to operate at scale. That means we actually have to get like pretty involved in how the roads work and how sanitation works. We have to talk to all the different tents and figure out how we can lift everybody up together. So actually about half of the work on Dask has just been social. It's been talking to the Pandas developers. It's been talking to the Jupyter developers. It's been talking to CPython, right? We've had to make lots of edits out of CPython to make things work well. But yeah, so that's the difference. Bazaar model, I think, is much, much better going forward because it creates a lot more space for innovation, but it's also a lot messier. And so it becomes a lot harder when you take that to enterprise.
I mean, walk me through the Python ecosystem, particularly in data, has exploded over the last several years, as you're probably very well aware. How do you choose or identify, I guess, to use the Bazaar analogy, like what roads to build, what roads to collaborate with other Bazaars on, or other tents, so to speak? Like I can't see that would be easy.
No, it's not easy, and most decisions are wrong. But the beauty of the Bazaar is that there's 50 different efforts in Python trying to do any one thing, and so a few of those efforts are going to succeed. Now in Dask, I think we were very intentional about choosing where to go, choosing how to focus our energies, and I think we were always very, very responsive to users, and that's maybe the focus of why Dask has been successful. So I've written lots of software projects before Dask that were not at all successful, and they were much more like cathedrals, where I had a grand vision and I wrote some beautiful software, and then no one used that software. And so early on in Dask, I said, look, I'm not going to make any feature until I get someone who's actually going to use that feature. I need to get someone on paper saying they're happy to engage.
Give me an example of one of the projects, the cathedrals that you built back in the day.
Like a failed software project?
Yeah.
Sure. I was really into logic programming for a while. So if you're familiar with languages like Prolog, I built a system called LogPy in Python, which provides a logic programming system. I did like a whole lot of meta programming for a long time. So I used to be very interested in languages that can make other languages in sort of a classic academic researchy perspective. More successful tools that I built, I worked on systems like Tools, which is sort of a variety of Python iterator collections. I worked on Theano back in the day. Theano was sort of the precursor to TensorFlow, PyTorch.
Yeah.
I worked on tools like SymPy, which were like Mathematica clones in Python. I worked on a pre-technology to Dask called Blaze, which was designed to reimagine computing in Python. And that was way too ambitious to succeed.
I can't remember if I saw that one or not. I definitely remember Theano back in the day. That was like kind of the first. Yeah, I think it was one of the first kind of. I don't know about modern, but it was, I think, one of the more modern approaches to like machine learning approach. But it was more of a. I think I recall it was like a linear algebra type library as well, or maybe I'm totally off base on that.
So Theano was a technology that you can think of it as doing the exact same things TensorFlow and PyTorch.
Yeah.
In fact, it was better than TensorFlow and PyTorch for long after TensorFlow and PyTorch came out. Had better performance. But you write NumPy-like code in your Python interpreter, and it then looks at your code and compiles it down to something that can run on a GPU. It can do automatic differentiation, backpropagation. It can do all sorts of things you need for deep learning. Theano and deep learning came out at about the same time.
Yeah.
And so that they sort of co-evolved with each other.
That's cool.
I actually wasn't doing deep learning at the time. I was doing a lot of like simulations for weather prediction. Which actually need a lot of the same technologies of GPUs and backpropagation that deep learning do.
Yeah.
But that's it's actually, so Theano is interesting because the transition from a more open source sort of community-based mindset to something like TensorFlow or PyTorch, which are much more corporate owned, is also happening a lot in Python today. Right? We're seeing a lot of these technological ideas being taken over by companies that are arguably much better at building software. They've got teams of hundreds of people, not 5 people. But also raises questions about that Bazaar model, right? We now got these little mini cathedrals inside of Python, and how do we have the Bazaar and those cathedrals interact?
Mm-hmm. Yeah, I mean, it's definitely happening, in the machine learning world with TensorFlow and PyTorch, as we talked about. But you also to kind of bring it back, and then we can always talk more about Dask and Coiled. But you mentioned earlier on there's some efforts to improve Python being driven by companies like Meta, for example. Can you maybe walk the audience through what those changes are that maybe we can expect in the next year or two?
Sure. So actually, I'm going to highlighting a different podcast, but
Okay.
the Talk Python to me has great
Great
interviews
podcast.
with folks. I was just listening to the Cinder Instagram podcast last night with Theano, who's been doing this for like a decade. There's also the effort around no-gil that's quite interesting.
No-gil's cool.
Yeah, so I mean, maybe I don't want to get too deep into the technical weeds. I'll maybe mention a couple of high-level things.
Yeah.
So first, JavaScript used to suck, and then Google got involved. They made a different VM for JavaScript called V8 that improved the performance of JavaScript quite a bit. Didn't change the language. Nothing really had to change. But there's a lot of research in programming languages that makes them run fast. And if you implement those well, you can get the language to run fast. It's tricky with a really dynamic language like Python or like JavaScript because the language is so unstructured, and that's tricky. What's fortunate though is that Instagram is one of the largest Python applications out there. It's a giant Django app, and Instagram I think costs probably many millions of dollars per year to run just in sort of electricity, and so the incentives are quite high for these large tech companies to make Python faster. And so they're really pushing what CPython can do to make it run well. There's technologies you think about. I mean, I'll just name a few things. There's immortal variables. There's ref counting systems. There's JIT compilation. There's a variety of weird technologies that I suspect are a little bit too deep than most folks will want to get into. But it's just nice knowing that Python will get faster over time.
Right. Yeah, and then you also mentioned the GIL. That's sort of the one of the elephants in the room as well. But I know there's a lot of there's work on this right now. So
I mean, so I would actually push back on the GIL. So actually, this is a good example. So when Dask came out, we got all of the PyData libraries to drop the GIL.
Interesting.
So to give some context here, so the global interpreter lock. I'm getting really technical here. I apologize.
It's fine. It's a technical audience. So
so if you're using the NumPy, Pandas, scikit-learn, TensorFlow, PyTorch stack in Python, the GIL doesn't really affect you. The GIL stops 2 Python threads from operating at the same time. But almost always in these more numeric libraries, that thread doesn't call Python code, it calls C or Fortran or CUDA code. Then it gives control back to Python. And so you can very, very easily use all the cores on your machine in parallel inside of a single process. So the GIL doesn't really affect the more numeric side of Python today. That's more or less solved. When Dask came out, we actually went to all the libraries. Now that people were using parallelism, we said, hey, look, you should drop the GIL. And we were the transition libraries off of it in about a week. It was actually not terribly hard. So the GIL is very useful if you're running a web server. It's very useful if you're dealing with text data. It's very useful if you're doing more sort of classic Python programming, but it doesn't affect the data engineering world much.
Yeah, interesting. That's good perspective. Kind of bring it back to Dask and this company called Coiled. Do you want to walk the audience through what is Coiled?
Yeah. So first, Dask is used everywhere. So Dask is, I think, if you look at the Python Software Foundation, they run a survey. Dask is used by something like 5% of users, whereas Spark is used by something like 11%. So we're sort of not quite as popular as Spark, but about a factor of 2. However, if you look at companies, Spark is everywhere and Dask is nowhere. So Dask has really done an excellent job of getting individuals to use it. It's a really pragmatic, really easy to pick up tool, but it didn't have sort of a for-profit company around it, and it didn't have an easy deployment story. It didn't have enterprise support. It really needed a company in order for other companies to feel comfortable adopting it more of an infrastructural core level. And so Coiled is that company. A bunch of Dask developers split off. We made a company around it. Mostly we focus on deployment, on
Mm.
making it dead simple to get Dask up and running in the cloud in a way that's secure, in a way that integrates with enterprise auth, in a way that deals with software environments, in a way that tracks costs and users, all the sort of standard technologies you'll see in any commercial open source SaaS company today.
Mhm.
So we provide that. We also provide enterprise support and just general guidance.
Sounds like managed Dask then.
Yeah,
Is
managed
that the
Dask.
way? So, I mean, walk me through this. If so if I didn't use Coiled and I wanted to spin up Dask on a cluster in the cloud, like, walk me through what that looks like, and
Yeah,
maybe why I'd want to use something like Coiled instead.
sure. Yeah. So first, you'd probably start using Dask just on your laptop. So that your laptop, probably you're using like a MacBook Pro or something. You've probably got 8, 10 cores in there, and you're using Pandas using 1 core. You can also have a hard drive that has a couple terabytes. If you use Dask, you can easily access 100 gigabyte data set or a terabyte data set and use all of your cores to churn through that. So you'll probably use Dask just on your laptop, and that's fine. Like the user experience for that is actually really smooth. Dask comes pre-installed with Anaconda. It's super easy to get running. It's trivial. Then once you sort of go a little bit to a larger scale, you're at sort of the multi-terabyte range, you're up down data on the cloud. How do you deploy Dask? So typically Dask is deployed on some other technology like Kubernetes or Yarn or an HPC job scheduler. And so what you might do is you might first say, so let's say you've got a bunch of Parquet in your company sitting on Amazon S3. You might ask your IT department to give you a Kubernetes cluster. You would then use one of the excellent open source projects around Dask, like Dask Kubernetes, to deploy Dask on Kubernetes. So you just first get access to Kubernetes, you deploy Dask there, you then connect from your laptop up to that Kubernetes cluster, and you can you're good to go. You'll probably be just fine. You can operate at scale, you'll be happy. Then IT comes to you and says, like, wait a minute, like you've got an open connection that's insecure from your laptop to that cluster. Like, you need to tie that down a little bit. You got to figure out TLS certs. You got to make sure everything is secure and nice. IT can maybe help you with that. It takes a few weeks. You have to figure out how to get your local credentials onto all of your Dask workers so you can actually access your data on S3. Sort of tricky. You have to maybe use Amazon Secure Token Service to figure out how to do that in a nice, secure, safe way. Maybe you want to get your colleague to use this cluster as well. Wait a minute, now you need to empower them on how to use Kubernetes as well. Well, you maybe knew how to use Kubernetes. Maybe you're like the early adopter in the company. Maybe your colleague isn't quite comfortable using that. You show them the ropes, they use it, they get happy. IT then calls you a few days later, like, hey, look, you've been burning thousands of dollars. What's this 100 node cluster that's been sitting up here for the last week? And it's just your friend left the cluster on idly over the last week. So using Dask at scale is actually really, really easy. Using Dask at scale in a way that helps you manage different libraries you're using and cost management and security is actually really tricky. What we find is that people go through this journey on their own, and that sort of top performing FTE, the top performing employee, ends up spending about half of their time just sort of minding the Kubernetes cluster that they're running on. And so most of our customers actually, they're mostly just looking to sort of get that employee back and have them start doing work again. Many people transfer from data science, data engineering into this role of sort of part-time DevOps that they don't necessarily want to do.
Yeah, been there myself actually. So that's but then it sounds like Coiled really does solve that problem. So
Yeah.
you're the ones managing all that, right?
So if you use Coiled, you can pip install Coiled, and you can import Coiled and create a Coiled cluster. You can hook up to your VPC. So you give us credentials to launch instances inside of your cloud account. And you say, hey, look, I want a cluster with 50 machines. I want it to have these libraries on it. I want it to turn off if it's been idle for more than 20 minutes. And then we manage all the cloud resources on your behalf inside of your VPC, so it's fully secure. Cool. We also give you telemetry. We tell you what's been going on. We tell you, how much money you spent parsing CSV files. Like, there's lots of things that we can do being in that more administrative role. We also have people who are, staffing this thing 24/7. So it's going to stay up. It's going to stay robust. We're also happy to work with you and make sure you're running things efficiently, right? So that visibility goes both ways, and we can really help people to make the most out of Dask.
It's interesting. So, I mean, you kind of mentioned that maybe, a person doing this on their own is going to spend 50% of their time managing maybe Kubernetes or whatever else. I mean, what is the ideal state, do you think, for a data scientist in terms of managing systems versus just doing the work that they were hired to do?
I mean, the ideal state is that the data scientist just looks at data, thinks about data, produces results in a magical way. Obviously, we're very far from that in a variety of ways, right? The data scientist position has to think about the right visualization library to use, data visualization as a thought process. They've got to think about the right parallel computing technology to use. Got to think about the right algorithms to use. It's tricky. The data scientist is sort of like a temporary role for analyst, and all of
Mm,
us are trying to turn data scientists into analysts faster than technology grows. So
mm.
it's
It's a really
I
good
mean,
insight, actually.
yeah, the ideal state of data scientist shouldn't really be a job, right? It's the person who wants to be an analyst, knows it's not possible in their situation, and so figures out about a bunch of technology in order to connect all the dots. Um, we try to solve the scalable computing problem so that data scientists can stop thinking about that. And there are 100 other companies trying to solve other parts of that problem as well. This creates a new problem for data scientists. They need to understand how these companies work and who to trust, who not to trust, what technologies to use. Um, Hopefully, in 10, 20 years, the kind of problems we're running on today will all be automated.
I hope so. It's
There'll be
funny
new
though.
problems to think about,
There will be
right?
new problems to think about. I think maybe the same. I hope the underlying themes change. I was actually just talking to several people about this the other day, over the week actually, where it's kind of funny. I mean, I've been in data for 20 years now, and it's a lot of the problems that I was seeing back then. The same sort of themes seem to be recurring, right? So, like, do I trust the data? Do I trust you know systems talking to each other? That's still a big thing as well. It's getting easier in some ways, but it's kind of a game of whack-a-mole where it just sort of moves
Hold
around
on.
the stack. So
I would say, well, hold on.
it's interesting.
It is so much easier
It's
today
way
than
easier
it
now.
was before, right? I mean,
Yeah.
like, let's take a look at one thing. Let's look at, data storage, right? So
Mhm.
previously would have been, I've got all this mess of CSV files. I'm trying to store it in some other file format. Should I use Parquet? Should I use Orc? Should I use HDFS? Should I use HDF5? How should I do this? And now the problems are like, look, I've just got so much Parquet data that my metadata is huge. I need to use Iceberg or Delta Lake,
Mhm.
right? But sure, there's still problems, but there's only problems because we've increased the order of magnitude by a
Mhm.
couple, right? And the problems we used to have are solved, right? Like the technologies that are available, the smoothness around them is just it's incredible. We've made a huge amount of progress in the last decade, and that has opened up new problems, certainly. But the old problems we were trying to solve are solved.
Yeah.
If you want to get SQL in the cloud, like there are 5 companies that do that for you amazingly well
Right.
today, and you're set, right? Now, if you want to do, deep learning on distributed data on multi-cloud systems, then yes, there are some challenges you got to work through.
Mhm.
But like, wait a minute, we're doing something that's like way, way, way more sophisticated today than we used to be doing.
Yeah. Yeah.
So I
I
think
can agree.
great success for technology. Unfortunately, people are always hungry for more.
Right. It's almost like we like to create problems for ourselves or something. I don't know. But actually, I do have a question here, an audience question from yes. Yes, I hope you're pronouncing your name right. Is Dask trying to be the T inside of ETL?
Dask is many things. So you shouldn't think of Dask as a technology like Spark. Dask is a technology like threading. So you can use threads or multi-processes to do lots of different things. So certainly Dask can do lots of ETL workloads. Um, I would say it's the full ETL pipeline, right? But we're working with other systems in that pipeline. Um, but Dask is also used to train models. Dask is also used to manage workflows in systems like Airflow or Prefect. Dask is also used to back up web servers, replacing systems like Celery. Dask is also used to construct live pipelines. Just to give you an example, like of sort of the wackiness people use Dask for, um, like one company was a camera company. And they've had 2 machines, a camera and a computer that were in the same box that they sold, and they use Dask to send signals from the computer to the camera and to send data back from the camera to the computer. This wasn't how Dask was intended to be used. It's a very easy way to do remote execution of code and movement of data and coordination. Now, out of that, you can build lots of different things, right? So one of the most common things is Dask plus pandas, which is commonly used as an ETL solution. But Dask itself is way, way lower level and is used in lots of weird, wacky situations. But yes, Dask is certainly trying to be the T inside of ETL, but is trying to be the E and the L and lots of other things too.
Yeah, I was gonna say
along with all the other libraries in the PyData space.
Cool. Hope
That's
that
a great
answers the
question.
Yeah, interesting. I guess what are some of the more mainstream use cases that you're seeing people use Dask for?
Yeah, I'll mention a few examples. So the first, what I just mentioned, so ETL going to machine learning, sort of the Spark replacement. A good example here is companies like Capital One use Dask to do credit risk models. They want to understand, they give you a credit card, they want to understand your credit limit and how valuable you are as a customer. In order to do so, they want to analyze large data sets, train those data sets on machine learning models like XGBoost, and they want to do that quickly. Dask allows them to shift from data sets maybe on a per customer basis to data sets on a per transaction basis. So not what is your zip code and your age and your gender, but what have you switched from paying your BMW lease to buying vodka, right? And so by going to that much, much larger data set, they're able to get a much richer model. And by using Dask and Pandas and XGBoost, both of which have native Dask integration, and libraries like Rapids for GPU acceleration, they're able to do that way, way faster. So that provides them the ability to get much better results. That's like the classic big data machine learning solution. Different application, so the same sorts of things, but on different kinds of data. So pretty much every weather service today, so the National Weather Service here, the UK Met Office in the UK, European and Australian equivalents, all use Dask to analyze the weather today. So whenever you are getting news that there's a hurricane about to hit your town, that's probably Dask is somewhere in the loop there. It's doing that same big data computation, but on a data set that's not tabular, but it's gridded. And so that's also quite common. Different example, technologies like Prefect are based on Dask. So Prefect is like an Airflow kind of technology. And so that's not a big data tool. That's an orchestration tool. I want to run these three things. If any of them succeed, I want to run this other thing. If that fails, I want to run this other technology as well and email somebody. And so that's a much more dynamic, much more ad hoc parallelism that gets run. So you can sort of maybe separate Dask into two bits, the big data applications, and there's lots of those. There's lots of variation in that. And then the sort of ad hoc parallelism. So Dask allows you to run arbitrary Python functions, they're on arbitrary objects, in an arbitrary graph of computation. And there's, again, lots of things that you can do with that. Prefect is a good example of that. The little silly camera example is a good example of that. Maybe another one I'll bring up. Brookhaven National Lab has a big cyclotron. They've got a big tunnel in the ground that they use, and they shoot particles and X-rays around that tunnel, and it hits different detectors, and that creates a lot of images, a high velocity of images coming off of that detector that they then need to process, put onto a screen, so someone can turn a dial and look at that image. And Dask is in the loop there, trying to figure out how to do that bulk processing, real time, giving things to users so they can again change the signals on the cyclotron itself. And so that's again shows the kind of variety in which Dask gets used.
Yeah, that's got to be kind of cool to see. This this library that you helped author being used and is probably ways you never expected. So it's I know I'd get a kick out of that. So
yeah,
got it. It's not really a question, but more kind of a statement here, and I'd like your thoughts on this. Srini asks, or says, scaling up Pandas seems like the killer app for Dask instead of having to throw Pandas code over the wall to some other scalable system. Do you have any thoughts on this?
Yeah, it is certainly a killer app for Dask. Again, Dask, there's no majority use case for Dask. Dask is used in lots of different cases. If you go to blog.dask.org, you can take a look at the results of our annual survey, and you'll see that Pandas usage is maybe like 40% of usage. So it's a there's a plurality, but it's not the majority. But to double down on what the person is saying, certainly not having to switch systems is very, very useful. What we see in lots of different companies is people today they have two teams. They've got sort of a researchy Python team that uses pandas, scikit-learn, PyTorch, and they've got a Spark team that operates at scale. And the Python team takes a sample of the data set, they build out a model, they iterate very, very quickly, and they really enjoy that experience. They get something that they like, and then they, as the person says, they ship it over the wall to the Spark team, and they then make it scalable. Then something happens, the model needs to be updated, they make some changes, they need to ship it back over the Python team, and it's that iteration cycle that's really expensive. That means evolution happens in the matter of weeks rather than hours or days. Dask allows all of that to happen on one system. You can use just pandas and scikit-learn and PyTorch on your laptop. You can then operate with larger data scales, still on your laptop with Dask. You can then operate at full scale on the cluster with the same workflow. Being able to go from your existing pandas workflow to a Dask plus pandas workflow is extremely powerful to folks. They really, really find value in that. It really reduces the time of iteration and gets to value a lot faster. People also just seem to like Dask. Like it has a strong, people have a lot of affinity for the project. It has a good, I think, user experience.
Walk me through that. User experience is a pretty, it's a big issue, and I think it's a bit underrated as well when we're developing software. I mean, what do you think makes a good user experience for software developers and data scientists?
I think there's no single answer to that. What I would encourage any software developer to think about is rapid feedback. Rapid feedback from users to understand what they need, what they're doing. I think it's like we made Dask. I was kind of operating a small consultancy out of Anaconda with Dask, and we made Dask in deep collaboration with users. It wasn't one group or 5 groups using Dask, it was 50 groups using Dask. And getting all of that feedback rapidly was very, very helpful. Second, I think feedback goes the other way too, from Dask to the user. I think we really focused on really informative error messages early on. We focused on a really impressive live dashboard that tells people what their cluster is doing. That's actually probably the favorite feature that people have, is just, the Dask dashboard tells you what every worker is working on, how much time you're spending communicating, how much time you're spending on something else. If deserialization is a problem, it just tells you everything that's going on in your cluster in a really rich information visualization kind of way. The biggest performance bottleneck that we find is most often user understanding. And so we're really performance oriented, not by making our code fast, but by making the user fast. And that also, I think, follows sort of the Python mantra. Sure, Python could be 10 times faster, 100 times faster, but it doesn't actually matter if the user doesn't know what it is they're doing. Libraries like pandas are actually notoriously inefficient, but people seem to work with it well. And it's that user experience, performance through user experience, that I think makes people a lot more productive.
Yeah, that's awesome. I think that's a really good point, and I think it's also, you can't overstate how much like less context switching really helps developer productivity. And I think the example we were talking about earlier with this kind of duality of throwing code over the wall to the Spark team, and now they have to translate this into Spark and so forth. Like if everyone just kind of settles on one thing, they understand it, they use it. It just works a lot better that way.
And the thing we settled on is just, for the pandas use case, it's just pandas. Like a Dask data frame isn't some different data structure.
Right.
It's just a bunch of pandas data frames floating around your cluster, and Dask is tracking all those pandas data frames. And so if you want to compute the sum on that on all those pandas data frames, Dask knows to run to all those different computers, call sum on all those different pandas data frames, and to then sum them up together, and it gives you that result. And so like our data model is the same. So if you have code that runs on pandas, it probably runs on Dask too. We invented as little as possible. And that means that a lot of existing infrastructure keeps working. Going back, this is how we play in the Bazaar, right? We're not making our own Cathedral. We are good citizens of the Bazaar. We're trying to figure out how to make new roads, how to clean things up. And that involves, that's really about being as unobtrusive as possible. And Dask really tries to play on that in that style.
That's awesome. She got a question here from hey, Todd. Hey, how's it going, Todd? He says, at day job, we use Dask a lot and have been experimenting with running our Dask code / task on Ray. Is this good or blasphemous?
Well, of course, I'm biased, right? I think Dask runs best on Dask, but it really depends. Let me try to take off my for-profit hat. It really depends on what you want to do. Also, switching back to Cathedral Bazaar, it's great you have these options, right? Dask was designed with protocols in mind, right? So the Dask scheduler is actually like the fourth Dask scheduler. People never saw the first few. Dask was designed to be swapped in and out. So first, it's fantastic that we open things up so that other technologies like Ray can try to run Dask code. I think the question is this good or bad? It depends on what you're doing, right? So just for context, Ray is another sort of distributed task scheduling framework in Python that came out a couple of years ago, coming mostly from the sort of advanced machine learning space. But we've got protocols. They saw our protocols. They implemented sort of the Dask graph on Ray's solution. If you're doing something that's embarrassingly parallel, that's really sort of trivial to schedule, like any tool is going to be fine. You could be using Spark, you can be using Dask, you can be using Ray, you could use IPython parallel. It doesn't really matter what you use. As you get into more complicated scenarios, you start thinking about what the technology you're using for is optimized for. Dask grew up in a space of ETL, of sort of pragmatic machine learning, of sort of ad hoc computations. And we focused a lot on making those run really, really smoothly. For example, something we find that was really, really critical was managing memory. That's something that we really think about a lot. Ray came out in the space of reinforcement learning, sort of more towards distributed machine learning. And now they're trying to get more into the ETL space, but they're optimized differently. If you're trying to do reinforcement learning, you should use Ray. If you're trying to use, pandas at scale, NumPy at scale, more ad hoc computing, I think probably Dask is better. I could be wrong. It's amazing you can try out both at the same time, though, and that's really the answer.
Yeah, that's really cool. Good question, Todd. So, kind of switching gears a bit. We're gonna, a bit time left. Before our call, we were talking about before we went live. We were talking about sort of just the technology and data landscape, and how things are changing that, I guess with respect to kind of how companies are founded, this proliferation of technologies. I know you had some thoughts on that. Do you want to talk more about that?
Sure. So just for context, Joe was asking, hey, what are you thinking about these days? What should we talk about? And what was on my mind is just like a personal thing, which is how did I ever get here? Like why I never intended to start a company. This was not my path, right? I'm like an introverted guy who likes to sit on a beach writing some code. That's my ideal day. And now suddenly I'm talking to investors and I'm, managing metrics and OKRs for a sizable company. And I was sort of questioning this in society, like why did we do this path of engineer to community leader to business leader? And that's not necessarily how it should work. I think I'm sort of questioning society's current mechanism. It's been an interesting ride. Yeah, that was the topic that I was sort of had in mind. It's interesting though. I think we used to depend on commercial companies to make our software. We used to depend on Oracle, on SaaS, on maybe Cloudera would fit into that as well. And now we depend on the open source communities to make our software. And that's strange, right? Because now there's this different set of people who are in control of the thing, but now those people have to interact in a corporate environment, and that is odd. So, I mean, Python is actually a great example of this. Like the Bazaar model is not what enterprises want. Enterprises want a cathedral. They want one person who understands the entire thing. They can deploy it all at once, and it just works. The Bazaar does not just work. I mean, it's very robust. It works, but Pandas releases an update that breaks something else. We're in this weird state where we've got non-business people interacting with business needs. My story is one example of that, but all of us are in that space. If Pandas breaks, who do you call? There actually isn't a person you can call today. Maybe Anaconda, right? They probably have enough influence to make something happen there. But how many companies depend on Pandas in a production way? All of them? Like I suspect it's 90% of Fortune 500. And that's just strange, right? We're starting to see for-profit companies get way more active into that space, which is probably good for enterprise. It might not be good for open source. It's weird having well-funded individuals operate in that bazaar, right? It changes the nature of the bazaar. So is it good or bad? Do you have thoughts on this, Joe? Or do people in the audience have thoughts?
Yeah, I'd be curious about people's comments on this. If they have any, just feel free to drop them in. Yeah, I mean, it's interesting. I see like a new type of a resume coming up too, where it's like you work at a one of the big tech companies, LinkedIn, Uber, Google, whatever, right? Work on an open source project. Maybe it's something you develop to, maybe you're hired to work on a team existing like TensorFlow. I heard TensorFlow has like 1,000 people working on it or something crazy, but I don't know. It's a lot. It's more than I have. And so, or you develop you work on a project, that solves a problem at this company, and then maybe a couple of years later, you leave, you talk to some VCs, you get funding for this, get a seed round, and off you go. But this happens a lot now. I personally know countless friends at this point who have taken this path, and they've been wildly successful. A lot of them. But I find this interesting. Is this sort of a new career path as an engineer, where maybe if you get the lottery ticket to work at these big companies and you work on a project, your next thing is to start one of these projects. That's one aspect of open source I'm seeing more and more, where it's sort of this you start out with an open source project, you form a company around it. That might sound familiar to you. That's one way to do it. The other is obviously the corporate sponsored open source in the beginning. I'm talking like TensorFlow, PyTorch, namely, and there's many others like that. But that's the incentive structure is definitely changed from like the good old days. Like I remember back in the early 90s. I mean, what was it? A shareware was the thing. That was kind of the model where I'd like physically mail you a check because I liked your software, sort of a donation. And now it's it's changed rapidly.
So I think, let me respond to a few things in that. So first, it's certainly an excellent career path, and I would encourage people, if they are financially motivated, to start a company. I think especially the funding environment today, like the amount of dollars floating around and starting a company is order of magnitude more than you'll get elsewhere. But I think it might not be good for the community. It might not be good for software itself. I think we're in a much more sort of like greedy optimization mode rather than a collective optimization mode. I think if you look at Python, a lot of people who made these libraries, who made this ecosystem, who made the Bazaar, weren't making companies, right? We were all academics. We were all working at scientific institutions. We have a background that I think emphasizes honesty and integrity a little bit more than you're kind of forced into in a for-profit world. At Coiled for Dask, like we try to straddle that. I think we've done a good job, I think, of being very community oriented. So Dask is not just run by our company, right? We're actually different than most companies in our space. And that Dask has folks at Anaconda, we got folks at NVIDIA, we got folks at Capital One, we got folks at lots of different companies that are all contributing to the project. Our governance structure looks a lot more like Pandas, a broad, well-trusted group, than a lot of these newer companies. And we're proud of that heritage. We've also solved, I think if you go to a Python conference today, people will talk about sustainability. How do we make sure that Pandas or NumPy or Jupyter is sustained financially, that they have enough money to keep the lights on? And we've solved that problem, right? VCs, large corporations, large governments, they help us solve the sustainability problem. But there's some balance in between sort of the fully community-oriented and not sustainable, and the fully corporate and entirely sustainable, or at least sustainable until the company crashes, which when it becomes dropped. We actually in Dask, we kind of actually think went all along that spectrum, and it's been interesting seeing what has worked out well and what has not worked out well. So as an individual, I totally encourage people to go start projects and make companies. It's a good way to make money. I would question as whether or not it's where we actually want our software to go. I think it'll get a little bit strange. Even right now, like I am curious about, or I question some of the motives behind some of the software choices that people make in projects because of the companies behind them. And that's a weird place to be in. I liked the case when it was just a bunch of my friends in a conference at a sprint trying to make a new software project. Like that felt a lot better. I had a lot more trust on the software itself.
It's almost like the software space is becoming gentrified in some ways. So, I mean,
I wouldn't say.
You don't think so?
Trying to follow the analogy.
Well,
So
I mean, look, go to any city right now. It basically most cities feel like the same city, right? It's sort of, corporatized, same chains everywhere. I mean, in some sense, I feel like software back in the day, it felt more. It definitely had a lot more personality to it. I would say, not to say there aren't. I mean, there's a lot of great projects out there and a lot of great people working on stuff, right? But what I'm saying is, like, I think it's just like a lot of things in this day and age. It's just gotten a lot more corporate. So
I think gentrification is an interesting analogy. Let's follow that for a second. So certainly previously software was a bunch of people kind of like living in tents, right? And like that didn't work, right? It wasn't a good place to visit. Things were broken, you couldn't get them fixed, and that's bad. So you want some gentrification, right? You want some money flowing into the system. And then you hit sort of the like inner city, but with artists collective kind of thing going on. It still has that community feel, but there's still a little bit more money going in there. That actually might be better than what it was before.
Yeah.
Then eventually hit sort of suburbs and maybe like the Malibu end state, where it's a bunch of folks living in their own houses, not talking to each other. And that's where things get weird. That's where you start losing that Bazaar collaboration. That's when you start losing things. As an example, when I was at NVIDIA, so NVIDIA is a big Dask shop. When I was at NVIDIA, we tried to build some roads between all the different GPU packages. So TensorFlow, PyTorch, Rapids, Chainer, Numba. And we tried to make sure that there were good, protocols to transfer memory and transfer data in between those packages, so you could use them both at the same time, right? It'd be nice if you could use, Rapids to load data in ETL fashion, and then use PyTorch, hand it off to PyTorch nicely. What we found is that all the projects were actually really open to this, except for TensorFlow. It was actually really hard to get TensorFlow interested in sharing data with other systems. It's not through any kind of nefarious nature. It's just like Google does their own thing. They're not that interested in collaborating. That wasn't their objective. And so like everybody else collaborated except for TensorFlow, except for Google. And that was unfortunate, right? TensorFlow had entered the suburb. They were no longer part of the neighborhood. They were no longer part of the community. Or if they were, it took a lot of effort to bring them back in. And that's where things start to get a little bit strange.
That's a good example. I wasn't going to mention this, but Web3, just because it's polarizing and cringy. But I was thinking maybe, we've been talking about sort of, some elements of centralization. Obviously, there's a big push, unironically or ironically from a lot of them from big companies towards decentralization. But somebody asked here, Jay Guzman, he says he could see DAOs to be game changer for some open source project, to create flows of capital, to empower strong communities not tied to Fortune 500, and then people be able to call someone at their Discord for technical issues. What are your thoughts on maybe this as a sort of an evolution of funding open source projects?
So first question, DAO, can you just make
decentralized autonomous organization, I think is what it means. So you get a group of people together, I think, write a quote smart contract, and then that sort of governs things. So
I think I'm fully in favor of everyone exploring this stuff. And again, Bazaar model, people should try lots of different things, right? It's only through failure that one succeeds. And I think you got to fail 10 times before you succeed.
I hope not.
I think I'll just answer broadly my views on centralization versus decentralization. I think that decentralization is really cool. And I've done like academic research on decentralized storage, all sorts of fun things. I think in practice, centralization is almost always more pragmatic. Like it's, if you look at like mesh networking, it's really cool. You think about using it in, war zones, but in practice, like setting up a single tower and have everyone talking to that tower just like is what people do. It's way, way better. Companies are not great, but like you want centralization up until a decent amount of scale, and then you want to switch to decentralized. For funding, so let me just walk through briefly Dask's funding. So we started Anaconda, and we were kind of a consulting shop, and that's like a very reasonable way to make software. I think it's actually probably the best way to make software that's useful. You get a ton of information. You build something that solves a lot of disparate needs. VCs aren't going to like it, but I think it is the right way to start if you want to get creative. We then went more towards sort of like nonprofit grants. So we got folks like Chan Zuckerberg to fund us. We got the Moore Foundation to fund us. This was, a more of a charitable giving kind of approach. That worked out really well. All of these were way, way better than like getting people to donate money on a website, $50, $20. I don't think that's the right way to get paid. I'm paid pretty well. I've always been paid pretty well. And I was always working on community open source stuff. So I think that's like, there are better ways than the donate button. We then switched to government grants, which were great. Like if you can spend a bit of time getting government grants, you can easily get $500,000, $1 million on a pretty steady stream. That's more than enough to maintain software. We then start selling SaaS, went VC. We then went to big companies, NVIDIA. We then went to sort of VC funding. Those also worked out fine. There's lots of ways to fund software. I think some of those ways push you more towards corrosive behaviors, but you don't have to. You can also maintain integrity during that process.
That's awesome. I mean, I hope more people can maintain integrity too. I think you definitely strike me as somebody who's just obviously a bit. I think I don't know, something drives you. It's a bit different than a lot of the other software founders that I will meet. And again, I think that we're all driven by doing great things at the end of the day. But I think that there's I sense you are.
I think
there's more of a higher purpose. It sounds like. So
I think a lot of the Python community, especially folks my age who came in during the sort of like scientific group,
yeah,
we're all very impact driven.
Mm-hmm.
If you talk to any maintainer of any PyData library, ask them what their PhD is in, and it's not in computer science. It's in like geophysics or it's in medicine or something. Right. Things will change, right? We're expecting folks to come in who are just sharks looking for VC cash to bail out, but I think we have a pretty good baseline of community and a baseline of again being focused on impact, and we've had tremendous impact, right? Python is used everywhere. Python has measurably improved everybody's lives, and I think we're all quite proud of that heritage. Hopefully, we can maintain it going forwards. And again, companies like Coiled are trying to bridge that gap between maintaining that culture, that integrity, and also playing with enterprises, make sure that enterprise can actually benefit from that technology. And that's an interesting tightrope to walk, but I think we're dedicated to walking that rope.
That's so awesome. Kind of wrapping up here. Thanks for the conversation. It's very fascinating conversation. I think we're here to talk about Dask, and I think we kind of went off on some really good paths, talking about software in general and sort of the state of affairs. So thanks for coming on the show. For people who want to learn more about Coiled, where can they do that?
Yeah, so there's dask.org and coiled.io. I recommend folks start with Dask. Again, you probably have it installed on your computer right now, but if you don't, Dask.org has lots of information. I also recommend examples.dask.org, and there's lots of examples on how you can use Dask in lots of different applications. Then, when you're ready to scale up to the cloud, or if you want enterprise support, let us know. We're at coiled.io. Or you can try pip installing Coiled, and you can get 50 node cluster in the cloud and start running on that at scale in a few minutes. Coiled is really, really easy to use. We really care about accessibility.
That's awesome. Again, thanks for coming on. Thanks to the audience for questions. Todd, thanks you for coming on the show as well. So it's a big Dask user. So yeah, thanks Matthew, and hope to see you at PyCon in Salt Lake City. Was it April? So yeah,
COVID willing.
COVID willing for sure. All right, take care.
Thanks, Joe. Thanks everyone.
Thanks everyone. Bye.